In this video module, we'll talk about pandas, and we're interested in particular in the aggregation and grouping functionality. And what I'm going to do in the video is go through a moderately detailed example, and my example is based on the chapter 3.08 from the Vanderplas book. And so what I'm going to go through in this video module is a completely different example, but my example is based on the example that he gives in this notebook. So you should definitely have a look at this one, and you'll see some different details and a totally different data set that I'm going to use. And so that information will combine, hopefully, with the information that I'm going to provide to give you a better view of this notion of aggregation and grouping. So our objectives for this module are threefold. First of all, I want to understand the data in the data set. And so we're going to work with a particular set of data. And so rather than just having random numbers that we use and random records, we're going to have a very specific data set that has meaning. And so understanding the data set is basically look at the data and understand what information it gives you. Then we want to pose some interesting questions that can be answered with the help of the data. So this notion of an interesting question, I want to elaborate that on just a little bit. Clearly, the notion of interesting, it's subjective and it's domain specific. So in other words, what interests me may not interest you, and vice versa. What I mean here from an interesting perspective is that the information would be interesting to somebody. Not necessarily me, not necessarily you, but to somebody. So think about an example like baseball statistics. Some people find the topic of baseball statistics very interesting, and some people don't. However, even if you don't find it particularly interesting, then hopefully you can understand and appreciate the data collection and data mining and the aggregation that goes into answering the questions. So with no real interest in baseball statistics, you might not be able to pose interesting questions, but once those questions are posed, then you can use the data set to answer them. And that's really what our interest here is in using the data set to answer questions. And that's why for some of the projects and homeworks that we do in my class, I want you to choose your own data set so that you can find something that interests you. And then what I'm going to evaluate is the posing of those questions and then the using the data to answer those. And then once we have those questions, again, we want to use NumPy, Pandas, the aggregation, at least for this video, the aggregation and grouping methods to generate information to answer the question. And so let me elaborate just a little bit on this notion of generating information. Some of the questions will be easy to answer. Like again, if you're in baseball statistics, you might say, what was, player A's batting average? And it's just an absolute number. Other interesting questions are things that are more subjective, like which division is the toughest in baseball, where what you want to do is collect some information and provide some numerical analysis that then provides information for an analyst who ultimately answers the question. And that's really what we're going to focus on here, is trying to extract interesting things like that from our data set. So let's switch to the notebook that we're going to use. This is available with the module. And so again, this is based on the material from the 3.8, so definitely have a look at that. But the data set that we're going to use is a different data set. If I can get to it here, let's see. Well, I guess I'll get out of full screen mode and just jump over there. Now jump back into full screen mode. There we go. And so here's our another example. And you can see the first thing I'm going to do is import Seaborn, just like he did in the chapter 3.8, except the data set that I'm going to use is called tips. And just as an example, if you go look at the data sets, I pulled up the data sets that are available through Seaborn, and you can see there's a whole bunch of data sets that are available with the package. And so the planets one data set is the one that Vanderplas uses. The tips one is the one that I use. And so let's have a look at this analysis here. So I loaded the data set, and then I'm just going to look at it. Remember that what the head function does is just shows the first 5 values. I can also change if I want to see more than 5. If I wanted to say see 10, I can give it a number and it would show me the first 10 values. And so what we see is a data set that has 244 records. Here's the shape, 244 records with 7 data elements, or 7 variables each. That has to do with a restaurant and tipping for meals. And so we see we have a total bill, we have a tip amount, we have the sex or the gender. I'm assuming this is of the person paying. I don't know for sure, but that's what I'm interpreting it as. Whether or not the person is a smoker, the day of the week, the time, and dinner and lunch, and then the size of the party. So that is this information that we're provided. And so the reason this information is interesting to me is I used to be a waiter. And so when I look at this information, I say, wow, this is interesting. Let's see what kind of information we can extract from this. And so the first thing I want to look at is, all right, so we have this raw data. Let's calculate the tip percentages that we have. So I'm just using the vector arithmetic here and computing the tip percent by the tip divided by the total bill times 100. And then again, if we look at the head, we can see the top 5 values, and here's the calculated field. So you can see what we in essence did is we just added a new column to our data frame. Okay, so let's look at some actual values. When we talk about aggregation and grouping, the first step is aggregation. And so what the function does here, let me just go ahead and execute it and then we'll talk about it, is I say, well, let's just extract the tip column. So tips, recall that when we use the column name in the Python dictionary format, we're actually peeling off this, let's see, this column right here, tip, and then I just use the aggregation, the mean, to compute the aggregate. And then I do the same thing for the median and the sum. So again, just note that since I have 3 different expressions on the same line in Jupyter, what's going to get returned to me is a tuple, which we have here. Here's the left parent and the right parent indicating a tuple where each individual value is displayed. So the mean value is 2.9982, the median value is 2.9, and the total over the entire data set is 731.58. And so just some aggregations, some aggregate values for our data set. Now, what information does this provide? It's a little bit limited, but when I look at it, the first thing I notice is the mean and the median are relatively close to each other. And so that would be at least some indication that we don't really have a very skewed data set. Again, it doesn't definitively prove that, it's just some preliminary information. So next thing is, well, over this $731, let's see how many total people are there. Recall when we did the shape, so if we go back up here to our shape, we have 244 records, but within each record we have multiple, or potentially multiple people who were involved in the meal. And so the total number of people is 627. So I look at this $731 divided by 627 gives me a per person value, and then if we incorporate the 244 for the number of meals, was it 244? 244 for the number of meals. That's a different piece of information. Continuing on, let's just look at the describe function, which is a built-in pandas function that gives us some summary statistics for each one of the numerical columns. So you can see that we have the total bill, the tip, the size, the percent. We don't have any of the descriptive columns where we talk about smoke or not, gender, day of the week, or any of that. So it's just the numerical column. So we have 244 records for each, and we can see the mean, standard deviation, min, then the percentile values, and the max. And so when I look at these individual values or the summary statistics, they just provide me as the analyst information about the data set that I'm looking at. And so the first thing that jumped out at me, as you can look at here, is I say, wow, who left a 71% tip? Okay, this comes again back to the interest level. As I mentioned, since I was a waiter, that's one of the things that I would gravitate to just because it's interesting to me. And so I look at this and this really jumped out. And I said, well, who is this? And so we can use the access here by using the masking. So I looked at this number 71 and said, gee, let's just mask the values using tips percent greater than 71 and say, who is this? Who are these values? I didn't know before I did it that there was only one, but I did know that when I look at this 71 that this masking operation would get me to that person. And so this looks to me, based on the data, is that it's a male smoker who ate dinner on Sunday with another person, and they left a 71% tip on their meal. And so again, be sure you understand what's going on here. This is, as I said, a masking operation. And so if we want to investigate that or make sure that we understand that, we can just pull this part out and say, well, let's take a look at that. So let me insert the cell below and look at that. And so now we just see that what we've done is we've masked our 244 records based on this condition. And this masking process is really important for data filtering. And you can see based on the result that we got when we then applied that to our data frame, we only got one of them, that you're only going to get one true value. So I'm going to have a numpy vector or array of length 244. All of them except one will be false. Okay, so now that we have that, let me go through and get rid of that cell. We don't need that. And the next question I'm looking at here, again, focusing on the maximum for some reason, is who had a $51 meal? So we had this 50.81 as the maximum total bill, and I say, well, who was that, or what are the characteristics? And so I did the same kind of thing, where I used a masking operation, and I'm just masking based on total bill for greater than 50. And when you execute that, you say, okay, well, this was another male smoker, it looks like, who had dinner on Saturday night with 2 other people and left a pretty nice tip, 19.68%. Okay, so moving on, suppose that I want to know what's the best day to work, right? As the waiter, the thing that I want to know is what day am I going to make the most money? So first thing, let's just start on a Thursday and say, let's just extract all of the values where the day is equal to Thursday. So again, another masking operation, tips day equal Thursday, and then pull those values out. And when I run the cell, you can see I'm getting all of the Thursday values here. And if we just scroll down to the bottom, you can see that we have a data set of size, I don't remember what the value is, 62 rows. So 62 out of our 244 are on Thursday. So now that I have those, I want to pick off the tip value. So here's that same query that I did before, and this time I'm just saying, well, I just want the tip, and I want you to use the aggregation, the sum function, to get that. So now when I hit enter and get that, I say, on Thursday, we had $171.83. That was the total tip for Thursday meals. So if my objective was to pick the number of days to work, or which days I wanted to work, I would then follow this same procedure for Friday, Saturday, Sunday. This particular data set only includes Thursday, Friday, Saturday, Sunday, but I could do the same operation and get those values, and I can make the comparison. So let me go back to my PowerPoint here and talk about one of the things that the Pandas provides is this process called split, apply, combine. And so here's the reference for this figure. And you can see that process that we just did, or that we just started, was we took our input, we split. In our case, we would split into days. So I took my total tip data set, split it into Thursdays, Fridays, Saturdays, and Sundays. Then I'm going to apply a sum function to each one. And so the process that I did was to split into Thursday and then apply the sum. And what I mentioned is we would also do the same thing for Friday and Saturday and Sunday, and what I would end up with is the sum value for each one. What the split, apply, combine process does is say, okay, well then we're going to aggregate all of those back together in order to make our decision, so that I can go and say, well, what was Thursday, what was Friday, Saturday, Sunday, that I would then use to make my decision. And Pandas provides a mechanism to do that all automatically using what's called the group by function. And so what I'm doing here is I'm taking tips, I'm applying group by, and I'm using the day as my group by factor, and then I'm saying pull off the tip column and then sum that. And so what we end up with is exactly what we were after. Here's the 171.83 that we got here when we did it individually, except this time I also have Friday, Saturday, and Sunday, and I didn't have to do those individually. By grouping and telling Pandas, it said, by telling Pandas what we want is we want these summary values. I want the total tips, but I want you to divide this up in day. What Pandas then did is this complete process, and basically took the input, did the splitting on day, applying the sum function, and then combining the results into a form that makes it easier for the person making the decision to incorporate that information. Looking at this syntax, a natural question, hopefully a natural question, might be, well, what is this object that gets created? So when I do tips group by, right, what actually gets created? So we can just use the type of to take a look at that, and we can see that what gets created is a data frame group by. So there is a custom object called data frame group by, and in the Vanderplas notebook they go into a little bit more detail about what that is and how flexible it is. What I want to do is now say, well, let's just add some information. So suppose instead of just having the tip, I also wanted to know the total bill. So I can just add that. Note that I have added just another column to our same group by, and now I have both pieces of information. I have the total bill and then I have the tip, and I've summed those values across day. I might also be interested in, well, let's look at the average tip and say, does some people tip better on any day? Because when I look at these total values, then there are different numbers of people who came each day. So instead of using the sum, I can also use the average. In this case, I've added the percent, right? If I add percent here, the sum of the percent doesn't really provide you any meaningful information, but the average of the percent does. So I just use a different aggregate function, but have the same basic structure. And now what I have is by day, what's the average total bill, the average tip amount, and the average tip percent. And when I look at this from our data, let's see, what would it be? The highest tip amount or highest tip percent would be Fridays, 16.99. The highest tip amount would be, what's it look like, Sunday, at 3.25. So again, information that would be meaningful to you if you were a waiter or trying to make a decision of what day you wanted to work. Okay, so we use the mean and the sum. We can also have multiple summary statistics by using the aggregate function. So now I still have my tips grouped by day. I've gone back to just total bill and percent. And instead of applying a single aggregate function like we applied sum or mean, I'm going to apply all three of them at once. And so now when I execute, I get a new group by data frame group by object where I have by day, and I have two basic groups. I have the total bill where I get the sum, mean, and median, and then I have the tip amount where I have the sum, mean, and median. And so it's very simple for me to get this meaningful information. Okay, so if I'm looking at this, I have a lot of information about by day. What if I wanted to look at by time? I wanted to say, well, is it better to work lunches or dinners? And so in this case, I just did a simple total bill, tip, and percent, looking at the median value by time. And so it did the same kind of process where it did the split, solve, aggregate, and combine. This time, rather than a by day, by the time of the meal, and the time in this data set is just lunch or dinner. And so now we can compare those values across day. I might be interested in a gender question, male or female, who tips more, male or female. Based on our data set, if you look, the percent looks like females give a higher percent, but males have a higher value, have more expensive meals. You can interpret that however you like. Smoker versus non-smoker. We saw the first two examples I did. The highest percent value and the highest meal value were both smokers. So maybe we're interested in looking at a grouping by smokers to just compare between smokers and non-smokers. In this case, I just aggregated pulled out the mean and the median for both the total bill and the tip. I can also add additional values, and so in this case, instead of grouping by a single value, we group by day, we group by gender, we group by smoker. This time I'm going to group by two different categories, pull out the total bill, the tip, and the median. Total bill, tip, and percent, and then just solve for the median. And so now when I execute, I see I have two level. I have Thursday, Friday, Saturday, Sunday, and then I've subdivided those individual groups into subgroups between gender. And so we have all of that information broken out for me automatically. And so again, one thing that you should be doing while you're following along here is just step back and look at what's being done with this one simple aggregation command. Is that I'm taking our entire data set and I'm doing fairly sophisticated aggregation and grouping for data collection. And the final thing that we show, and I pulled this again directly from the Vanderplas notebook and just modified it for our data set, is that it's really easy to loop through the groups. So we have the tips group by day, which we've explored a bunch, or tips group by time or gender or whatever by the grouping. And so this object data frame group by has an iterator, and the iterator returns two different values. It returns the day value and the group value, or the day in this case because we've grouped by day, and then the corresponding group. And so all I've done here is I've just looped through and printed three pieces of information. I've printed the day value, so this is going to be our Thursday, Friday, Saturday, Sunday. The group shape value, so this is how many observations, so the group is going to have a shape of how many observations for each day, and then I just summed the bill, the total bill. And so when I execute, we get a simple table that in this case says on Thursday you had 62 records. Total bill was $1,096. On Friday we had 19 records, 325, and so on. And so it did this totaling. And in one of the analysis up above, when we were trying to compare between days of the week that you wanted to work, here's where this information becomes useful, right? Because if you look at the average tip or the average value, that provides sort of that comparison information, but this additional information of the count or the shape of the individual group provides more information for you to make an evaluation. So that's what we're gonna, that's the end of what I wanted to do in this video module. Again, the basic idea here is that we are posing interesting questions, and then how do we answer those questions? And what we evaluate really is not so much what you find interesting, but how you took that interest and then use the data set to provide data to answer those underlying questions.